Okay, so today we're going to talk about solving quadratics algebraically. There are many techniques you can use with a graphing calculator, and such like that, but I'm going to focus on the algebraically. And I'm going to break this into two parts. This first part, we're going to focus on solving by factoring and a little thing called completing the square. And then in part two, we'll focus more on like the quadratic formula and also show you how to find something called the discriminant of the quadratic, which is basically tells you what kind of answers you're going to get before you get them. But let's dig into part one here. So some terms you need to know. First one is x-intercept, which is points like this right here and here. If this is some quadratic function, f of x, or parabola, its x-intercepts occur in this particular instance at approximately the point 3, 0 and at -1, 0. That would be these coordinates. Now, what's special about them is they're of this form. Some value for x and then a y value of 0. So when you have an x-intercept, whether it crosses those at those 2 points or here, or whatever the case may be, they're going to give you some value for x and then always 0 for y, which brings about our next term here, a 0 of a function. By definition, it is the value of the input x that makes the output f of x equal to 0. So in other words, it's what makes f of x equal 0. Recalling that f of x is another name for y, it gives you these locations. So whether I call it an x-intercept or a 0, it's referring to these locations. What value of x makes y 0? You might know a third term called roots. Roots are if I take a quadratic equation, ax squared plus bx plus c, where a, b, and c are some real numbers. The roots are called the solutions to the quadratic. Now again, if I write something like this, f of x is ax squared plus bx plus c, only thing different is like here, the f of x has been replaced with 0, which is what we just talked about here. So whether I call these roots, whether I call these x-intercepts, or whether I call them zeros, I'm really looking for the same thing. It's just a different terminology, maybe a little different representation, but I'm looking for the values of x that will make f of x equal to 0. Axis of symmetry, it is a line that divides a parabola into 2 equal halves. So I got a parabola like this that in this case is concave down, or say I got something like here that is concave up. My axis of symmetry is going to go right smack dab down in the middle of it. And if you have an equation of the form f of x equals ax squared plus bx plus c, your axis of symmetry will have an equation of x equals negative b over 2a. You say, well, what's the b? What's a? B is the coordinate or the coefficient in front of your x term. A is the coefficient in front of your x squared term. So that will be the equation of that line. Again, anytime you have a vertical line like that, it's always x equals some number. Now what's cool about that is this. This location here on this parabola, you might have heard it called before a local or a relative maximum. Whereas the one that's concave up, this I would call a local minimum. Regardless of which you have, whether it's concave up or concave down, I'm here to tell you the coordinate of that vertex point will be of the form negative b over 2a for x, and f of negative b over 2a, you don't need that little comma there, for your y. So what's cool about that is this. Notice here, this x coordinate for your vertex matches up with what x equals in your axis of symmetry. That is not by accident, because whatever this x coordinate is here, that's what your axis of symmetry will pass through. So just some cool stuff. Definition of a quadratic. Again, it is an equation of the form ax squared plus bx plus c. It is called a second degree polynomial. What makes it second degree? Having a highest power of 2 makes it second degree. You might also notice here, you say, well, what's up with the a can't be equal to 0? Is that like a domain restriction or something? No, it's not. I mean, this is not a deal where we have to, where we don't have to like restrict values on x in order for it to be defined, to avoid division by 0 or square rooting a negative. I'm not worried about restricting the domain of x. What I'm saying is this parameter, this coefficient a can't be 0. You might say, well, why not? Well, maybe you learn like the old school way. If like somebody says, don't do that, and you say, well, I'll show you, I'm going to do it anyway, so let's do that. Let's take that a coordinate, or that a value, that coefficient, and let's make it 0. Well, 0 times x squared is in fact 0, and when I add that to the rest of this, I'm left with just bx plus c. Maybe you're familiar with the term y equals mx plus b, the slope-intercept form of a line or of a linear equation. That's what I get here, only instead of mx and b, I get bx plus c. So when you take away that x squared, it's no longer second degree. It's no longer a quadratic. It's a line. So that's why we have that restriction there. I must retain that x squared. So zeroing out a, not a great idea. Completing the square, I'll let you kind of read through this. You can write it down as you will, but we're going to go over this in a little bit more detail. But this is a very key step into solving by completing the square. Taking half of b and squaring it. So let's go. Starting off, find the zeros by factoring. Again, to find zeros, we must first take f of x and make it 0. Fair enough. So we did that. Since we're solving by factoring, I want to factor x squared plus 5x minus 14, which factors as the quantity x minus 2 times quantity x plus 7. From there, the next step is to take each factor, the x minus 2 from right here, x plus 7 from right there, make them both equal to 0, and then basically solve. If you add 2 here, I'm going to get x equals 2. If you subtract 7 here, I'm going to get x equals negative 7. Now, maybe your question is, why once I get it factored do I set each one equal to 0? Well, it's a little thing called the zero product property. If you're not sure what that is, let me tell you. It basically says this. If I have two things being multiplied and they equal 0, like an a or a b, or an x minus 2 and an x plus 7. See, when you factor, you're writing two things that multiply to make something else. In other words, x minus 2 and x plus 7 multiply to equal 0. If I multiply two things and they equal 0, then you really only have a couple of options. Then either the first one, the a is 0, or maybe the b is 0, or perhaps both a and b equal 0. Say, I don't get it. Okay, let's say a is 4. That would give me a times 4 equals 0. Can a equal 3? Does 3 times 4 give me 0? No. Can a equal 9? No. What if a is 0? 0 times 4 is 0. So, in essence, when you have two things being multiplied, the only way they may equal to 0 is if either the first one is 0, the second one is 0, or perhaps both. Okay, this one, I go ahead and set it equal to 0. Factoring wise, I'm not sure how good you guys are at factoring when your leading coefficient of your squared is not 1. I will tell you this, that this polynomial does actually factor down to 2x minus 3 times x plus 5. And again, if this method is giving you trouble, I'll go through a different one of these and show you like how I got these factors later on here. But once again, once you get it to that step, take each factor, make that equal to 0, make that equal to 0, add the 3, divide by 2, I get an answer of 3/2 and -5. And I say, well, what does this mean? Well, basically what it means is this. When you find the zeros, the x-intercepts, the roots, when I say that I have a 0 at x equals -5, what that means is that at the point -5, 0, and also at the point 3/2, which is like 1.5, my graph will cross those points. And again, since my leading coefficient is positive, it's going to be concave up. So I can come up with a pretty good graph just by knowing the zeros. And then if I went back and used that x equals -b over 2a, I could actually find the location of that point at -b over 2a, comma, f of -b over 2a. Just saying. Okay. I'm giving you an A and a B here. If you want to pause the video and take a shot at these yourself, go ahead. And then come back when you're ready, and then I'll work them out here. Okay, again, I'm solving by factoring. So I'm going to factor. Again, since my leading coefficient is 1, it's not really a hard thing to factor. So what factors of 12? Again, if I take 12, that's 1 and 12, that's 2 and 6, that's 3 and 4. Do either of those either add or subtract to make -7? Yeah. -3 and -4, -3 and -4 do. They add up to -7, and they also multiply to make the +12. Then I set them both equal to 0. Add the 3, and I get 3. Add the 4. Really nothing to it. Okay. I promised I'd walk you through like the factoring behind 1 when the leading coefficient is not 1. So I'll show you one technique here. I mean, there's many you could choose from. You know, if what I'm showing you freaks you out, I mean, go with what you learned in your algebra class, and I'm sure your teacher can help you with it. But again, I'm not trying to force a method on you. I'm just saying, here's a method. If it helps you, great. If not, use what does work for you. So I take this, make it equal to 0. Now, to factor, I'm going to show you a little thing called the AC method. Again, this is ax squared plus bx plus c. If I take the a times the c to 3 times the 4, I get 12. And how do I multiply to make 12? Well, 1 times 12 will do it. -1 times -12. -2 times -6. 2 times 6. 3 times 4. -3 times -4. All of those will multiply to make 12. I'm looking for the ones that when I add or subtract will make -7. And that's these guys. So what I'm going to do is just a little rewrite here. Instead of saying this 7x, I'm going to use this -3 and this -4. I'm going to break it as a -3x minus 4x. So really all I've done is just rewrite the negative 7x as negative 3x and negative 4x. Now we do it by grouping. So I'm going to group the 3x squared and the negative 3x together, plus the other group will be negative 4x plus 4. What do each group have in common, or what does each group have in common? Well, this one has a 3x in common, leaving me with x minus 1. What do these guys have in common? Well, notice here my x is positive and here it's not. So I'm going to actually factor out a negative number, and they both have a 4 in common. So negative 4x divided by negative 4 is x, and 4 divided by negative 4 is 1. So I have the common factor, x minus 1. And after you get rid of that, I'm left with a 3x minus 4. So that's how that factoring technique works. It's one of the methods. Then you set each factor equal to 0, and you solve. So you add 1, I get an answer of x equals 1. Here you add 4, and you get 3x equals 4. And then divide by 3, and your other root is 4/3. And it works like that. Which brings us to the one that probably drove you the most nuts in your algebra class. The completing a square. You know, maybe you got it just fine and I'm just preaching to the choir here, or maybe it just really gave you a lot of headaches here. So I'm going to kind of walk you through this, and I'm going to try and show you a technique that to help you understand what you're doing here. I mean, I don't know what your algebra class was like, but I know a lot of times you might just be given here, follow this step, that step, whatever step, and all that. And I found that a lot of times when you do that, you're looking to memorize steps rather than to really understand what you're doing. So again, I'm not a big fan of doing it this way. The only reason I did it in this video that way, or I'm showing it, is because I know for some people having those steps and writing them down might help them to practice originally to where they can get better at it. So I'm going to walk you through the one with the steps, and then I'm going to show you, you know what, if I really would rather you didn't use the steps, I want to show you where this came from and how this whole thing works. So again, get all the x's on the same side. I already got it. The x squared and the 8x are both over here. But what I didn't put in the steps is anything that doesn't have an x, it's got to go. So that 12 doesn't have an x, I'm going to make it go away. And then I'm going to put like this. You'll see where this comes into play a little bit later. Now, in step 2, I said divide both signs by the leading coefficient of x squared. Well, in this case, my leading coefficient is 1, and I know that dividing by 1 isn't really going to affect this at all, so I'm not worried about it. So that step 2 is really here in case of something other than 1, like a 3x squared or a 5x squared, something along those lines. Okay. Step 3, divide the x coefficient b by 2 and square it. You say, well, what's b? Remember, this is a, b, and c. So a is 1, b is 8, c, well, it was 12. So I'm going to take this b coefficient 8. I'm going to divide it by 2, and I'm going to square it. 8 divided by 2 is 4. 4 squared is 16. And I'm going to add it to both sides. That's where I put this little box. So what did that do? Well, again, I am a huge fan of solving by factoring. It's quick, it's easy, a couple steps, you're done, it's fast. You know, some of you can do this stuff in your head. Problem is with factoring is not everything factors. So when you do this completing a square by taking this half of the b and squaring it and adding it to both sides, it makes sure that even if the original didn't factor, and this one does, by the way, it factors what, x plus 2, x plus 6. Even if it didn't factor in the original, it will create something here that does factor. Factors of 16 that add up to 8 are positive 4 and positive 4. and negative 12 plus 16 is 4. And you go on to step 6, which is writing it as a perfect square, meaning if I have x plus 4 times x plus 4, that is the same as saying x plus 4 squared. So what in effect did I do? I completed a square. I made something squared. Now, the part that always bugged me about this is that you work your tail off to get, this something squared or to complete the square. And then the very next thing you're going to do is say, well, it's been nice knowing you. You're gone. So then I get x plus 4 here. And over here, I know the square root of 4 is 2, but I need you to think about something here. My highest power is 2, which tells me I'm going to get 2 zeros. And just by solving this one like this, if I just say 2 equals x plus 4 and I subtract 4, that's only going to give me the answer of negative 2 equals x. So that's what this is all about. Again, maybe you know your quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. There's a plus minus in front. That's so that you do get the 2 answers. So I write it either as 2 equals the x plus 4 or the negative 2 equals x plus 4. And then when you subtract, I get negative 6. Again, did I have to use completing the square to solve this? No. I could have factored it a lot easier, a lot faster. But again, not everything factors, so I wanted to start you off with one that's a little bit manageable before we get into some of the tougher ones. That's completing the square. Now again, I'm not a fan of just writing down steps and following steps, so I'm going to show you, why is it that I do all of these things? What is the whole thing? And I want you to basically get past just trying to memorize a set of steps or a formula. So here's what I'm going to do. I'm going to draw some shapes. First one I'm going to draw is a square that measures x on each side. So if I were to find its area, the area of that squared would be x squared. Then I'm going to draw a rectangle that measures 1 by that same height of x, and its area 1 by x is x. Then lastly, I'm going to draw a little square that measures 1 by 1, and its area is just 1. And what I'm going to do is, I'm not going to worry about this 8. I'm going to make it go away since it doesn't have an x. And again, this is like saying 0. So I'd have 0 minus 8. So I basically get negative 8 is x squared plus 6x. And then if you follow what I did in the last one, I know there's going to have to be something that I add to do what I want. So that's kind of the setup. So here's what I want to focus on. I want to just focus on the x squared and the 6x. And when I talk about completing the square, I'm not talking about can you factor something and get it to be something squared. I'm talking about a physical manifestation, a hands-on square. So x squared, well, I can write that as this rectangle that measures x by x. That's an x squared. So I'm going to take these terms here and put them in terms of something graphical. So there's an x squared. And what else do I have? I have a 6x. So what happens if I put all, I'm horrible at art here, 1, 2, 3, 4, 5, 6. So what if I put all of my 1 by x's right there? Does that make a square? Not feeling it, no. So maybe I need to regroup these x's. So again, I still have my x squared right here. So check, got my x by x, x squared. How about this time, instead of doing all 6 of my rectangles of area X on the one side. How about I do this? Here's an X, here's an X, there's an X. Then here, I'm going to put the other half of those 6 X's here and here. Now I might say, well, big shot, that still doesn't make a square. We're not done yet. It would make a square if I did this. If I just filled in these little boxes here. How many little boxes did I fill in? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I just added 9 of these little 1x1s, now I've got a square. Or in other words, I've just completed the square by adding 9. Which factors? X plus 3, X plus 3. See, if I were to take the measurements of this, this would be X, that's a 1, 1, 1. So what are the dimensions there? That's an X plus 3. Here, X, 1, 1, 1. That's an X plus 3. Or I get an X plus 3 times an X plus 3, or X plus 3 squared. So actually completing the square actually comes more from completing a square. And then once you get it to this step, then it's easy peasy. So why do I take the b over 2 and square it? It's the same thing I did here. Is you have to take like your half of the x's and split it up on both sides. So then I just solve algebraically. I square root. So I get plus minus 1 is x plus 3, which means that either 1 is x plus 3 or negative 1 is x plus 3. And then you subtract. And I'm going to get negative 2. And I'm going to get negative 4. That's completing the square. Let's take a harder one. Again, go ahead and write it down. And if you want to pause and then come back and see how you did, that's fine. What makes this one a little harder is that in this case, my b is odd. That's going to add a little bit of excitement to this and make it a little more challenging, but we'll manage. So again, 12 doesn't have an x in it. It doesn't get to play in the reindeer game, so I'm going to tell it to go away. And again, my goal is to complete a square. You know, x and x like this. So I'm going to get x and something squared. But to do that, I need to remember how we had like that little shape here. And you had to like add on those little boxes. So there's going to have to be something that I add on to both sides to actually make it a perfect square. So how do I find it? I take my x's, my b, and I cut it in half. And then what do? I square it. And negative 7 squared is 49 over 2 squared is 4. I know you could say, well, couldn't I say that the negative 7 halves is negative 3.5 and you square it, it's 12.25. If you must use decimals, feel free to do so. I'm going to leave them as rational numbers here, as 49/4. It's really not a big deal. So I'm going to put the 12 over 1, and I'm going to multiply by 4 over 4, which will give me negative 48 over 4. But more importantly, it gives me common denominators. And negative 48 over 4 plus 49 over 4 gives me 1/4. Now, here's where you might freak out a little bit. You say, I don't know how to factor this out. Like, what factors of 49/4 will add up to negative 7? Well, I'm going to help you with that. What I'm going to tell you is that when you take this b over 2 right there. Before you square it and get the 49/4, if you just take the b over 2, that'll give you how this factors. Negative 7/2 times negative 7/2 will give you the 49/4. And if you take negative 7/2 x minus 7/2 x, that gives you negative 14/2 x, which is negative 7x, which is your middle term. So if factoring it out with those fractions freaks you out when you're doing completing the square, when you take the b over 2, this part right there, before you square it, that's how your thing will factor. So I get this. Then I square root. Then I square root, so I get x minus 7/2 is the plus or minus square root of 1/4. So, well, square root of 1 is 1. Square root of the 4 is 2. So the square root, the positive or negative square root of 1/4 is plus minus half. And then we just finish it up with, that means that either a positive 1/2 is x minus 7/2, or, remember, plus or minus, or maybe it's negative half. That's x minus 7/2. So to finish, I add 7/2 to both sides, and 1/2 plus 7/2 makes 8/2. And 8/2, 8 over 2 is just like saying 4. Here, if I add 7/2 to both sides, that gives me x equals negative 1 plus 7. That's going to give me 6/2. And 6/2 is 3. Let's do one last one here. This is a one where our leading coefficient is not a 1, which ordinarily can make this whole completing the square thing a real pain in the neck, but I'm going to show you something cool. I can tell you that each and every term in this mess is divisible by 3, so that is precisely what I'm going to do. Then from here, I'm going to have my x squared minus 10x plus something. Tell the negative 25 to take a hike, or the negative 20 to take a hike. So if I add that, I get this. Now again, to complete my square, I'm going to have to add something to both sides. How do I find that something? Well, I take half of my b. My b is negative 10, and I square it. Negative 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 to both sides, which on the right side will give me a 50. And on the left side, x squared minus 10x plus 25 will give me x minus 5, x minus 5. Remember what I told you? When you take your b over a before you square it, negative 10 divided by 2, negative 5, negative 5. It gives you your factors. So that gives me x minus 5 squared is 50. So we've completed our square. Now we solve. So I'm going to x minus 5 equals plus or minus, let's talk about that root 50. I know I can break that down as 5 times 10. 10 is 5 times 2, so pair of 5s get out. The 2 stays in. So that's really, instead of saying plus or minus root 50, it's plus or minus 5 root 2. So then how do I finish? Well, I go 2 spots here. I go that either x minus 5 is positive 5 root 2 or x minus 5 is negative 5 root 2. And when I add 5, well, 5 and 5 root 2 are not like terms, so I'm just going to get x equals 5 plus 5 root 2. That's one answer. Or if I add 5 here, I'm going to get x equals 5 minus 5 root 2 as my second root. If you want to play the lazy mathematician way, you could say this. You could say that x is equal to 5 plus or minus 5 root 2. That is the same as saying both of these together. I hope that gave you a good start, and we'll talk about quadratic formula and where that comes from and the discriminant in our next video. Thank you.